This question is definitely hard. It's very conceptual, it's very abstract, and it's possible that in 8th and 9th grade you haven't yet learned this theorem. Though I don't think that that is a barrier to getting this question right, you basically just need to follow the instructions. So let's start by just clarifying what they mean. The triangle inequality theorem states that the sum of any two sides of a triangle must be greater than the length of the third side. Okay, so that is a simple thing that we can follow just by coming up with some triangles and testing out some sides, testing out some numbers. They do give us two of the side lengths, 6 and 12. And then the answer choices are kind of, in a way, giving us the third side that we can try out. So let's just try choice A. What we would need to do is draw a quick triangle. Oof, it's a terrible triangle. Let's try that again. That looks like a triangle, kind of. So 6 and 12 are two of the sides. And then since it says x is less than 18, let's just pick a side that would be less, but just barely, right? So let's pretend that x is 17, because that would be true, right? 17 is less than 18, so we are picking a number that would make choice A true. And now we want to see, if we added two of the sides, would they come up to follow this theorem, right? So the sum of any two sides, so let's do 6 and 12. If we add those together, we get 18. So let's stick that in, the sum of any two sides of a triangle. So 18 must be greater than the third side. Yes, 18 is greater than 17. So that checks out. We've created a triangle that makes sense according to this theorem. What that means then is 17 is a possible value of x, which means that A is a possible answer choice. But it is not the only possible answer choice. First of all, choice C kind of includes the same idea, right? 17 would be a possible value of x, and that could be between 6 and 18. So that's still valid there. But if we try choice B, 17 wouldn't be included in that. And we can verify that B is wrong by choosing a number that would work, right? So they're looking for now numbers that are greater than 18 to be the value of x. So that would be 19, right? Let's try that out. If we made a similar triangle, except now we've got 6, 12, and 19. Again, if we add these two numbers together, we get 18. So again, the sum of any two sides, so the 18 must be greater than the third side. But 18 is not greater than 19. So this is bad. We've created a triangle that doesn't even make sense, that doesn't exist according to this theorem. So what that means is B is wrong. It's forcing us to pick values of x that don't work, that don't fit this theorem, that don't fit this instruction that we were given. So B is not going to be right. And since D contains the same thing, that's also going to be wrong. So we can get rid of two answers just like that by kind of straddling the fence on 18. Is it bigger? Is it smaller than 18? That's really the first question. Then we need to think about this other piece. 6 can either be a limit or it could not, right? So choice A is saying we can go all the way to 0, basically. You know, we can't have a side length that's negative. We can't really even have a side length that's 0, but we can get really close. We can get really, really small. We can go to 1. But C is kind of limiting us, right? It's kind of saying we have to stop right before 6. So what we want to do, especially with inequalities like on any question, is we want to kind of test the limits of the inequality. So what we want to do is, in some cases, we want to pick numbers that fit the inequality. So we did that with choice A when we picked 17. We did that with choice B when we picked 19. We chose numbers that fit the inequality, that made sense with the numbers. But in order to test out choice C, what I want to do here is pick a number that doesn't work, okay? This would be a number like 5, right? So let's pretend x is equal to 5. That does not make sense in choice C, right? Because x has to be between 6 and 18. 5 is not between 6 and 18. But x equals 5 would work in the choice A, right? So 5 is still less than 18. So what we found here is like a pivot point. We found a number that will tell us which choice is right and which choice is wrong. If 5 makes sense as a potential triangle, then A would be the answer because that choice includes 5 as a possible value of x. If 5 doesn't make sense as a potential triangle, then choice C would be right because it doesn't include 5. So we want it to not include this bad answer, but A does, and we wouldn't want it to be included. So let me show you what I mean here. I'm going to draw another triangle here. I'm going to try to do it a little differently. This is a little harder to draw. But basically what I want to do is get a side length of 5, a side length of 6, and a side length of 12. We can see now 12 has gone from just being a kind of a regular old side to now it's the biggest side in the triangle. So that kind of changes how we want to think of things. I want to still add two sides and see what they give us. But 5 plus 6 is 11. So 11 is not greater than 12, right? We're comparing those sides, right? It's kind of like if we go back to this formula, 11 is this part. The sum of any two sides, that's 11, must be greater than the third side, which is 12, right? So is 11 greater than 12? No. This doesn't make sense. This is an impossible triangle. So because 5 doesn't work, C is the answer. Let me just reiterate why. I know this is hard to wrap your head around, but basically, choice A includes the number 5 because 5 is less than 18. True, that is a true statement. But what we found is, according to this theory, if we just follow the instruction, 5 shouldn't be included. It should be left out. It causes a problem. Now, if we put 5 in this X here for choice C, we've got a problem, right? Because what this is basically saying is 6 is less than 5. No, it's not. 6 is greater than 5, right? So it is still true, this part's true, that 5 is less than 18, but this part is false. So 5 does not work in the inequality for C. And that's good, because 5 gave us a bad result, right? So we don't want it to work. We want it to be left out. And C is telling us to leave it out. So that is why it is the answer. This is hard. I understand that. So don't prioritize a question like this. This is the only time in all of the digital materials that I've seen so far that they've even asked about this formula. So it's not like it comes up a lot, but it is helpful to have real numbers, no matter what we're doing in math on the SAT, to be able to have real numbers to kind of think about this in a less abstract way. And in this case, since the instruction was to add two things together, by having an actual number, we could do the addition and we can compare it and think about greater than and less than more easily. But inequalities do pose this kind of problem where sometimes we want to test numbers that work, but other times we want to test numbers that don't work. And that's so hard to wrap your head around. So remember, you do have scratch paper. You can write things down and try to keep track of it as best you can. But yes, inequalities will be difficult. Conceptual things will be difficult, but as much as possible, write it down and write numbers down. And hopefully the conceptual weird stuff will start to make more sense and you can get even these hard questions correct.